Says, Deandra rides her bicycle along a straight road from home to school, starting at home at time t equals 0 minutes. So we got to realize we're doing minutes. And arriving at school at time t equals 12 minutes. During the time, the interval is 0 less than or equal to t less than or equal to 12. So this is your interval. They write intervals in this notation as well. Okay, that's called interval notation. And this one down here is called set notation. Her velocity b in the miles per minute, so here's our what we're talking about, is modeled by this piecewise function up here. So this is up here, this is v, velocity. All right, find the acceleration of Deandra's bicycle at the time t equals 7.5, indicate units of measure and interpret its meaning of the context. So that means we are finding v prime of t, which is a of t, and we want to find that. Now we want to find that when t is 7.5, so we should probably stick in here 7.5 and 7.5. Now can anyone tell me what is acceleration compared to velocity? The derivative, which is the slope, right? So I hope we all know that the slope is going to be change in y, which we, in math, you let delta y be change in y over delta x. The y's are on top. So I'm going to go ahead and do my units over here. Now this is velocity. What does it tell me velocity is right here? And that's the y. So my change in y is miles per hour, and then that's going to be divided by the x. What's the x values? What's 0 to 12? Minutes. Now we got a little problem here, don't we? Oh, it is miles per minute. My bad. So we probably need to put miles up here so we don't get the m's mixed up. Miles, we'll abbreviate minute, minute. So you can write miles per minute, or you can put that as miles per minute squared. All right, now, this is velocity, right? So what again, somebody just said it. What is acceleration compared to velocity? Slope. So we need to find the slope of 7.5. So to me, it looks like 7.5 is right in here, isn't it? And this is the line, the velocity segment we're looking at. How can I get the slope of that little segment? What did you learn back when you first doing slopes from graphs? Rise over run. Then you go rise over run. Didn't we do that? Yeah. Now, I can't tell. Is that 0.1, 0.2, 0.3? Yes. All right, so your rise going down, the rise is down, so it's negative 0.1 over the rise to the right is 1. So this is negative 0.1. So this is negative 0.1. So now we need to find that. The acceleration, which equals the derivative of velocity, is negative 1 mile per minute per minute. Is that right? No. Is this one going to be right? No, because, well, it might be. Let's see what they say over here. Miles per minute's all they have there, right? So that one doesn't work. Let's go down here to C. It says negative 0.1. Deandra's velocity was decreasing. Okay, look at this. Decreasing by a negative. What does decreasing by a negative mean? That's a positive. That's a double negative. Decreasing negative is positive. So this one doesn't work. So this better be it. Deandra's velocity was decreasing. So there's the negative 0.1 miles per minute at the time t equals 7. Do we all see that this has the nut in it? The nut is velocity. That's the noun. The units is this part right here that we knew we had up here. And then this is the time. So there's the nut. This is D. Who's got a question on that one? All right, then on the next page, number 4. Number 4 says, let P of T represent the population of a city in millions of people, and T represents the number of years since 2010. Which of the following statements correctly and thoroughly interprets the meaning that P prime of 2 equals a half? So what's P prime compared to P? Can't hear you. Derivative or slope. So what's going to be my units of measurement here? What's the y part? Is it the P or the T? The P of T, that's y. So what goes on top? Millions of people over, what's the x part? Per year, millions of people per year. Okay, so we know that P prime of 2 equals that. So let's see what we got. P is population is growing. Let's look at A. In 2010, well, okay, we got a little problem here. What's 2010? The number since 2010. So 2010 represents T equals what? 0. Is this saying 0 here for T?
No.
No, so it can't be this and it can't be this. Does this represent 2 for T? Yeah, so it's one of these. The population is growing by 500,000 people. Is that enough information?
No.
No, because we know it's millions of people per year. So the population is growing by 500,000 people per year. Is that what we need? So it looks like a double D. Question? Yeah. Okay, number 5. Now this says we need a calculator. So get your calculators out. I'm going to tell you the buttons to push. Grass clippings are being placed in a bin where they decompose from 0 to 30. The amount of clippings remaining in the bin is modeled by this. So that's how much is in the bin, where A of T is measured in pounds and T is measured in days. Find the average rate of change. So this wording right here is humongous from the interval. Indicate units of measurement. Average rate of change. What does that mean? What is it telling us if it wants average rate of change? What? Okay, it's not a derivative. Anybody else want to take a shot? It kind of is, but it really isn't. What is it? It's the old slope formula for math, from Algebra 1 and pre-algebra. So when you see average rate of change, you need to immediately think, we need this. That's what we're looking for. So in order to use the old slope formula, I need what? What do you got to have to use the old slope formula? 2 points. Do we have any points? No, but we have p-values. So we need to find A of 0, and we need to find A of 30. So somebody get out a calculator. Maybe we don't need it for the first one. So we plug in 0, we got 6.687 times 0.931 to the 0 power. What's anything to the 0 power? So it's 1 times this, so this is 6.687. And then we come over here and we get 6.687 times 0.931 to the 30th power. And we're going to write down a whole bunch of decimals here. What do we get here? What? 0.78. I need more decimals. That's it? It didn't have more? 29 ... Right? Because this isn't the answer, so I can't round that. Okay, so then what we need to do is do the slope formula. So we would say the average rate of change is, and then we would put 6.687 minus, and then you should hit on your calculator second answer, or you highlight this thing and type this whole thing in over 0 minus 30. Now, can anybody tell me What goes on top for our units? What is it? Grass clippings, and it's in what? Pounds. So we got pounds, LBS, pounds of grass clippings. I'm abbreviating, over, time is measured in days. So there's the units, pounds of grass clippings over days. Now this, I can tell from looking at this, it's going to be a negative answer, right? Because well, actually we got to do another thing. All right, so average rate of change, and it says indicate units of measure, there's my answer. I do not have to calculate it out. If you can round that, you can round this answer. Did anybody calculate it out on their calculator? What'd you get? So negative 0.197, that's what you said, right? Pounds of grass clippings per day. In other words, the grass is rotting away at that many pounds every day. They're losing 0.197 pounds. Okay, so the grass clipping is changing at that rate. Yes.
Why is it not day squared since it's acceleration? Just because it states that pounds and day?
Why is it not day squared? Okay. It's not acceleration. A is just the letter they're using.
Okay.
This is not position, velocity, acceleration. It would have to be talking about position. And if you look again, see, this is your Y. A of T is your Y is pounds. T is days, so your Y is pounds per day. Okay?
Yeah. The A is 3 off.
Yeah, that's just a nut. That's like having F of T, H of T. All right, down here, find the value of A prime of T. Now, what does that mean? No, that's not velocity because A is not acceleration.
A is position, right?
No, A is just an A. It's just like F of 15. A is my function.
Oh, so now
A is this function. This is not a position function. So, what does A prime of 15 mean we're going to do on this one? We are actually going to do the derivative on this one. So you're going to write this down because you can't just put a bald answer. And you're going to type math 8. So do math 8. And then underneath the 8, we're going to use an X, not a T. So put X down there and then arrow, and we'll go over to the, does it go over automatically? Yeah. Okay, so it goes over, and then you're going to type in 6.687 parenthesis, 0.931 parenthesis, and then hit your caret button on the right side above your division symbol and type in an X, and then arrow to the right, and it's where X is 15, and hit enter. What does that give me?
negative 0.163.
Is it 3 or 4?
It's 4.
Okay, now in this class, I round almost every time, but you can truncate, and what truncate means is just drop off everything after the third one. Now, again, this is derivative, and A is, again, pounds per day, so this is going to be pounds of grass clippings per day. Now, we are supposed to interpret the meaning in the context. So what does that mean to us? Remember nut, we're going to use nut. The rate of change of grass clipping, pounds of grass clippings. There's my verb, pounds of grass clipping. Now, if you watch my videos, I told you I'm going to use the word change, is changing by negative 0.164 pounds of clippings per day. What have I I not put in there yet? Time at t equals 15 day. That would be the interpretation. So I got my N. My N is the pounds of grass clipping. My units is right here, pounds of grass clipping, and T is right there. The rate of change, I guess the rate of change is really my noun. Question. Okay, so what we're going to do the rest of the period is you're going to work on this. If you are done with this, you can start 4.2 video and start doing those problems. Anybody else got a question on anything? So I'm hoping you guys will keep doing this stuff. And I'm going to put this video on in a little